Hello, I'm Mark Bees, your host for this webinar on managing complexity and risk, which is sponsored by Dassault Systèmes. In this webinar, we will learn about digital twins as a methodology to deal with complexity, business transformation as a driver of productivity and growth, the factors that drive business transformation in capital projects and turnarounds and maintenance, and how to enable change with the right digital strategy. We will hear from Ralph Rio, Vice President with ARC Advisory Group, and Dr. Paris Trivedi, Solution Director with Dassault Systèmes. Paris is a chemical engineer with a PhD in environmental engineering and has been involved in various oil and gas projects for more than 20 years. But first up, we will hear from Ralph, who has been an industry analyst with ARC Advisory Group for 19 years. He covers engineering and design tools and current market dynamics. Ralph, over to you.
Mark, thank you for that very nice introduction. I'm going to talk about managing complexity and focus on the asset lifecycle management aspects. And I'm going to talk about managing that complexity using digital twins and how digital twins can help out and fold into that. Now, we have this model for the total asset lifecycle and managing that lifecycle. Typically, it starts with a project, building a new plant, for example, where we have some design and build going on. Then there is handover. Then there is the operate and maintain and the types of applications that monitor that, or asset performance management, or APM. After running it for a while, the product may change, or they'll find new ways of doing things, and there'll be some modification request that comes in. And this goes into a portfolio, rank ordered. Those that go above the line become funded projects. And that project then starts this iterative process again. So asset management really doesn't have a start and a stop. We see it as an iterative process. Now, across all this domain areas, the D&B, operate, maintain, et cetera, there are easily, in any one company, could easily be 1,000 or more applications. We certainly have the design authoring tools, project management, et cetera, on the left. And then on the right, we have a slew of programs for asset management, as well as operations and production management. And unfortunately, each one of these applications has their own database. And because the data does not match exactly, the people using those applications can easily come to different conclusions, and arguments result. So this all becomes much easier to manage if there is a common database and common use of data. Now, just focusing in on the handover process for a few moments, in the past, or maybe currently in your particular operation, the design and build process occurs. Maybe you've engaged with an EPC, and at the end of that design and build, there's this handover process where all the documents related to the asset are given to the people who will operate and maintain the asset. As a result of digital transformation, we see this converging, and we see people moving to more of a continuous handover, where the operate and maintain people at particular stage gates will meet with the design and build people and pick up the appropriate documents, and also feed back to the design and build people aspects of the project that they need for good operations. Now, let me talk about this a little bit. I'm going to mention, I think a pump would be a good example. So in the designers, we'll be looking at things like, flow rate, how caustic the materials are, maybe some other parameters, and from that, decide on a model number for a pump. So there's a whole bunch of design parameters that end up giving a model number for a pump. And I apologize for some of you who are on the design and build side of it. That may be a little oversimplification, but the point being that you get to a model number. Now on the operate and maintain side, they take that model number, which is the piece of information they need, and they get a bill of materials so that when they need to maintain that pump, they know what parts to order to replace maybe a worn out part or something in the motor, in the pump rather. So we see that if you think about this iterative nature, on the left-hand side, it becomes very important to preserve the information, all those design parameters for the next project, because you know there's going to be another project. Research has shown that engineers on the design and build side typically spend 30% of their time looking for information. So by preserving that information, you can significantly reduce that waste. And then on the operate and maintain side, there are applications in the reliability space, in the maintenance space, in the MES, production management space, that use data to manage those particular domain areas, those aspects of operate and maintain. And it would be very good if they all had access to the same information. And then the shared information in the center is the example of the model number. All right. So I'm going to take this now to a whole nother step. That's kind of where we've been and maybe where a lot of you are now. And I'm going to want to put this in the context of digital twins, how they map into this asset life cycle. And there are two types of twins that I want to talk about here. A set of twins on the left based on the 3D model. And in this particular case, that image is an upgrade where a pump is being added to increase capacity. So there's some modeling and simulation needed to make sure the pump will function properly in that context. The construction sequence, do you put the pump part in first or the motor part in first? How do you attach it to the piping, et cetera? So the construction sequence can be simulated to make sure that there isn't any rework needed. If that motor, for example, is 36 inches in diameter and the door is 32 inches wide, you'll know about that problem well before the motor shows up at the door, and you can plan ahead for it. And of course, there's a virtual commissioning because we've got a motor being added, a pump, being added. How is that going to work? How you do load balancing and all that other kind of stuff. Now moving over to the other side, the operate and maintain side, and the role that digital twins have there. Here we see them being much different. Here we see them being a math algorithm, or nowadays more likely machine learning, that represents how the asset behaves, and may not be a 3D model, but maybe just a mathematical algorithm. This has been adopted in a big way, IoT analytics for predictive maintenance. And we see a very high adoption rate for that because unplanned downtime is really onerous. It's ugly. When the equipment goes down in an unplanned fashion, it usually interrupts production, can create safety problems. So previously, before digital twins, doing predictive maintenance was a custom project and usually was expensive and was difficult to sustain because as things changed around it, the application would break and people would go back to the old ways of doing things. We also see this digital twin being used for process optimization, particularly in oil and gas and bulk chemical. And energy management is typically found in facilities like in big ones like airports and large commercial buildings. And these all involve access to IoT data in real time, and then layering some analytics on top of it, whether it be first principle math or machine learning. And then alert is generated that goes to somebody who can do something about it. Like in the case of predictive maintenance, we would recommend that it goes to the maintenance planner, who can then do some assessment and decide whether or not to schedule a work order on it. All right. So for a moment now, I'm going to go back to the left side of this slide. What I talked about above is really the as designed and maybe getting into the as built model. We're starting to believe that the next step is to have this as built model become part of the handover process, so that the operate and maintain people can have models that better represent the as maintained condition of the asset. If the changes were occurred to improve the asset's performance, that would be part of the individual asset's as maintained condition. And of course, in the case here where we have 4 different pumps, the as maintained model would be one for each one of those pumps. And then when a maintenance person went in to make a change, they know exactly what's inside that pump and its history, and can maintain it and change it much more appropriately. Now, so this slide starts to talk about adoption rate. There are some on the left side, there are very strong drivers around adopting digital twins. And these are all typical ones for metrics around design and build of a project. So number one, you want to meet schedule, you want to be within budget, and you want to be within specs. And the 3D model provides the means to simulate, to make sure you get it right the first time, which lowers your risk. So you're much less likely to run into a situation where it isn't quite working right. You can have a lot of rework you got to do, which of course then increases costs, puts you behind schedule, and creates a lot of project risks. So the 3D model mitigates a lot of the problems typically seen with a design and build of a project, and assures that you're much more likely to meet your metrics. Now on the operate and maintain side, we see drivers that are common with production and maintenance. So again, that unplanned downtime, it interrupts your ability to make product, which directly affects revenue and usually impacts whether or not you can ship the product on time. And as a result, you have customer satisfaction issues, which can also impact revenue. Inventory, this one is more for the discrete industries. One reason you have work in process inventory is so that if an upstream machine goes down, the downstream machines can continue to run. Well, if you have a good predictive maintenance digital twin in there and you get to near zero unplanned downtime, then you can reduce that inventory, which improves the balance sheet and the metrics of the executives and also the production people. Asset longevity usually plays in the process industries. The asset lasts a lot longer when you maintain it properly and use it properly, operational, don't overdrive it. And that asset longevity means you don't need to take cash out of your balance sheet and use it to buy assets. So that makes your balance sheet look a lot better, and also improves the criteria which the financial analysts use to evaluate the company's stock, and the stock price goes up. And of course, all the industries are concerned with safety. So we see these drivers on both sides driving a very high growth rate for the adoption of digital twin in both the design and build area and the operate and maintain side of the manufacturing industrial processes. And with that, thank you for listening to me, and I'll turn it back to Mark.
Thank you, Ralph. That was very interesting. Looks like there are a lot of opportunities for people to explore the concepts and the power of digital twins, which will ultimately end up very positively impacting their bottom lines. So thanks for that. And now we will turn it over to Paris. Paris, over to you.
Well, thank you, Mark, for an equally wonderful introduction for me. And I would also like to say that, Ralph, thank you very much for giving us such a good insight in terms of where the industry can really should be moving towards, and where it is actually already moving towards. And I want to go ahead and capitalize on that complexity so that we can help our customers and our friends in the industry to start their strategic business transformation. So what I would like to first start with is always figure out, where does somebody get an idea of a business transformation or a digital revolution, however you want to call it. Well, it already exists in the other industries. And our industry is recognizing, or particularly oil and gas and chemicals industry and the power industries, they're all recognizing that there is something to be learned from the other industry. And this all starts because they see a common factor. The common factors are productivity and growth. Given the dynamics of the market, these two are essentially the bottom line metrics to account for their individual success. So what does it really mean in the other industries? If you think about aeronautics, aerospace and defense industry, almost 20 years ago, they started to kind of think about how they can revolutionize their approach in terms of engineering, procurement, construction, design, and then operations and maintenance. And here are some examples where you can see, that some of the leaders in the aeronautics industry are definitely thinking about business transformation through either reducing the design changes, improving their own replicability, increasing their own predictability. And you can see some of the outcomes that they have been using to measure their transformation. Same goes for the transportation and mobility industry sector as well. We all are now enjoying cars that are very well connected. And so they're great examples of not only just a good engineering work, but they're also great examples of what it means to kind of operate and maintain the car or maintain your asset in real life time. And it goes the same thing for the industrial equipment. There is a quick and a fastest movement today in terms of improving the digital twin type of a concept and making it, bringing it to life in the industrial equipment world. If you talk about the marine and offshore, they see productivity in terms of improving the shipbuilding and the delivery, and then also improving the modeling aspects. They started to recognize that there are parts of their own projects that can be modularized and that they can be very easily turned into digital packages that allow them to improve their productivity by almost 30 to 33%. That is a significant number when it comes to the transformation and the metrics around it. The chemicals industry, the special chemicals industries, has also started to see that, especially when you start talking about their initial R&D efforts. They're very much focused on improving their product development time so that they can get results better than just the what is known as 20 to 25% success rate for the first time product in the market. Do we have something to learn from this? Well, what did they really look into? They definitely understood that there are different areas of strategic improvement in their own businesses. A lot of them have really started to think about model-based enterprise, model systems-based engineering approach, account for everything as a single system, and make the data become the the liquid gold, the answer for all of their decisions. Figure out a ways to improve the supply chain, whether it is standardizing their vendor bidding, their vendor evaluations, making sure that the supply is well synchronized between their different sites, their different locations, their different shops, and then identify where they could actually go with a future factory approach to make sure that they have well choreographed logistics when it comes to not only just building their products, but also delivering their products. And the most important part is now the virtual field connectivity. They want to make sure that they have all of the data during the building part. They would like to kind of use that as a great baseline to make sure that they are able to provide an additional service to their customers in terms of operations, maintenance, and prevent the unplanned downtime, prevent the pains of unexpected events that the customers would face on a day-to-day basis. That allows them to build a confidence. Well, isn't this very similar to the quests in our industry? All the customers are really hoping to go ahead and improve the supply chain. They would like to go ahead and provide a better experience to their customers. They would like to see that they can move into a data-driven decision making. That's what they refer to as the digital transformation. So you can see there are many parallels in what they started as a quest versus what our industry is hoping that they can start conquering as well. Well, why is this drive becoming suddenly so important in the last, I would say, last decade or so? Why is there a need to recognize that we need to kind of transform our industry? First fact is that our projects, the major capital projects, are becoming more and more complex, and they have more complexities in terms of the regulatory requirements, the customer expectations, the resource management. You can talk about the lack of skilled labor, and also accounting for all of the costs from the non-production or non-quality type of factors. And if you look at these numbers, they're quite astounding. They are on the conservative side. And if you talk to any customer, they would say, well, we actually experience more than 70% of our projects to be over budget and delivered late. Delivery and execution is one aspect, but then there is another aspect to it. That is post-delivery. Okay, you may have delivered late, but does it really meet the operational readiness? And that's where the quality really starts to come in question. It's not that the customers, it's not that the producers in these industries are lacking in quality. It's just that they don't have the ability to go ahead and account for all the factors that build into this complexity. Even more complicated when we talk about existing facilities that need turnarounds and maintenance or expansion type of projects. Now you have to talk about bringing in the data from the previous phases of this facility. I think Ralph pointed out that there is an increasing need for improving the shared content between the two sides of any facilities, whether it is on the CapEx side or the OpEx side. There is a need to increase the complexity, overcoming by providing a shared content of on both sides. Again, this is where they recognize today that there is an increase, a continuous increase in scope, increase in budget, and that is really boiling down to more than $2 million of cost project overruns per day. These numbers are, again, on the conservative side. This is what the industry-wide surveys are really showing. But on an individual level, these numbers can go even much higher. So what drives these business initiatives? here's a way to kind of think about it. Even within a certain facility, there are various what I would refer to as disciplinary islands of excellence. Within each of those islands of excellence, they have got various well-established databases and well-established software systems and tools. Even if they are homegrown, they are doing fairly very well within the discipline. However, the problem really lies in the fact that in order for that island of excellence to be more effective, it has to work in collaboration in concert with the other disciplines and the other islands of excellence. And make sure that there is a continuity in near real time. And today, that is not fully accomplished in our industry. And hence you can see these silos are really resulting in a lack of traceability, high amount of rework, challenges in terms of optimizing the resources and delivering the projects on time, delivering the products on time in the market, making sure that the quality of the product and the quality of the information behind this is reliable, and it all boils down to a significant impact on the profit margins.
Thank you, Paris. It's interesting to see the benefits of business transformation in other industries and the imperatives for change in oil and gas. Before we turn to Ralph and Paris for their final words of wisdom, I would like to introduce you to Dassault Systèmes solution, which enables the digital twins that Ralph outlined and addresses the challenges that Paris discussed. It's called the 3D Experience Platform. It brings all of your islands of information together into a single collaborative experience to synchronize everything and everyone throughout all lifecycle phases of your projects and operations. With it, all the stakeholders in all the different phases can connect with each other, collect information, visualize it, and simulate ideas and work processes like maintenance to improve and validate them. It also provides analyses to ensure the right decisions are made and acted upon, and when they are acted upon, that those decisions follow a standardized path, allowing projects to be governed better. This is the foundation for what we call a 3D Experience Twin. This reduces the distance between the real and virtual worlds to virtually zero. The 3D Experience Platform allows you to manage all of your projects in a single collaborative environment. It offers many benefits, including improved collaboration, better project control, and increased productivity. So, gentlemen, before we end the webinar, I thought it would be interesting for you to leave our listeners with some words of wisdom. What do you think it takes for people to begin the business transformation journey?
Well, Ralph here, basically it's get started. It's simply having a conversation sometimes with the operating people. What's the most problematic piece of equipment? This doesn't have to involve a lot of criticality analysis. You can just pick a problematic asset, build a mathematical algorithm that represents the asset or machine learning, pull in some equipment data. And I recommend that, this is not doesn't have to be a big data project. It can be the small data specific to a particular piece of equipment. It could be 5-6 parameters type of thing. In the case of a pump, it would be some process data like the pressures, incoming, outcoming, maybe temperature of the material going through, so you have an idea what the viscosity is. And then also equipment data. This is key. Bring in some equipment data like the current draw, temperature of the motor, and maybe some vibration. And you could build up a very robust predictive maintenance algorithm around that and use that to prevent unplanned downtime. And I recommend you choose a problematic machine rather than something low risk because people won't notice the change. If you take a problematic machine, they will notice the change, and you'll be able to get some traction for a wider program. So that's an example of how to get started.
Ralph's example is a bright way of saying start with a very simplistic approach. Take something that is consumable and achievable in a reasonable amount of time. But just with that one more aspect that our customers to bear in mind is that in order for getting that dream vision of digital twin, do make sure that it is sitting, the whole program is sitting on a very strong foundation of a strong information model where you're able to account for all of the different factors or different sides of the assets, whether you talk about the geography of the geographical information of the asset, the system information of the asset, whether you talk about all the work breakdown structures associated with it. I'm going a little bit technical on this, but what it really is important is that in order for you to have the very optimal and a successful digital twin, it does require you to think from building a program that is sustainable on people, process, and technology. The people and processes would really help to identify where are the low-hanging fruit, and the technology will help you to identify how do you really build a strong foundation to make those processes more effective and to make those people involved in the process feel successful and good about their efforts.
Thank you, gentlemen. That was very informative. I hope our viewers got some takeaways that they can explore as they begin their business transformation initiatives. If you would like to learn more about Dassault Systèmes and how we enable business transformation, please visit 3ds.com/energy-materials. Thanks for watching and have a great day.